Hi, and welcome to another video tutorial of the week. In this video we will designing, constructing and programming a IoT-based smart streetlight project. The IoT-based smart streetlight uses both LDR sensor and PIR motion sensor. When the IoT-based smart streetlight is powered up, it checks if it's nighttime by the LDR. If it is, the LED light on the streetlight comes on but on half the illumination. But if it isn't nighttime, the LED lights remains off. The PIR to check if there is human motion, and if there is, it will illuminate the brightness of the LED lights. And if there isn't, it keeps its brightness at minimum. This will conserve the energy of the backup battery. This project is an offshoot from the piezoelectric generator project, as the project DASing itself acts as an actuator to the PCT generator. That means that the powering and control of this IoT-based smart street light is done by that bigger project. But don't worry, you can totally build this part separately and on your own. The controlling of the IoT-based smart street light is done on the Blink IoT dashboard. We can see there the voltage of the backup battery as well as the voltage generated by the piezoelectric generator. But what makes this project stand out is that the smart street light model has an online dashboard button here, which can be toggled to actually determine if the smart street light should come on or not. This means that if the admin or the owner of the design checks the level of the backup battery and feels like it wouldn't be enough, he or she can turn off the smart street light remotely from anywhere around the globe by just toggling the online switch. Now that we have shown you how the project design works, let us dive into how to actually build it. Stay tuned and ensure you watch until the end to get the full step-by-step guide. While you are at it, you could take a moment to subscribe to our YouTube channel if you haven't done that already. Also, share, like and leave a comment below if you have any question for us. Alright, let us begin. We begin first with the schematic or circuit design drawing. The circuit diagram is made up of the PIR motion sensor that is connected to the microcontroller development board, Arduino, through a header pin. The LDR sensor is also connected to the Arduino using this header pin out. We used an NPN transistor to amplify the LED lights, and the base of this transistor was connected to a 10 kilo ohms resistor that is connected to a digital pin on the Arduino board. All the header connector pin out were labeled accordingly. You can read the blog post with link below to understand better. During the programming of this IoT-based smart streetlight project, two Arduino codes were used. The Arduino Megaboard used a code that controls the other processes in the piezoelectric generator, which is the mother project design. There is also the Arduino code for the ESP01 module that gives the IoT-based smart streetlight remote monitoring and control. This is the code we are explaining here. We used the Blink credentials to get the Blink IoT dashboard access. Then used a parse code method to accept data from the Arduino Mega board, after which we sent it to the IoT dashboard. When setting up the Blink dashboard, we had to log in first. After that we have to create a project template. We clicked on Create New Templates. When the pop-up form comes up, we typed in the name of the template. After that, we selected the device and the method of connectivity. In this case, we choose the Wi-Fi method and the board of choice was the ESP8266 board. You can add a description if you want. The next stage would be to add some data streams. This is pretty simple, just create one, make it a virtual pin, put down the name and save it. Do that for the number of data streams you want to create. In our own case, we just needed 3 data streams. And we have named them effectively. The last step would be to set up the web dashboard. We use 2 charts to show the backup battery voltage and the piezoelectric generator voltage. The switch is to control the state of the smart street light. There, now it is done. We can proceed to testing the project design itself.
Dangerous times, don't fly too high. Be sure to keep the ground in sight. Fly forever if you keep it tight. Love the world, but keep the sky on your mind.
The mother project design made room to test the smart street light and also a 12 volts DC bulb. When connected, the 12 volts DC bulb comes on and we can be sure that the backup battery was fully charged. However, for the IoT-based smart street light to work, the mother project needs to be powered on. This is because the mother project design, piezoelectric generator has the Arduino Mega used to control the smart street light. Once she is turned on and the smart street light is connected, we can test out the performance of the IoT-based smart street light.
Dangerous times, don't fly too high. Be sure to keep the ground in sight. Fly forever if you keep it tight. Love the world, but keep the sky on your mind.
And this is how we designed and built an IoT-based smart street light. Thank you so much for watching this video. If you so have any questions for us, kindly leave a comment below.